Okay. So today you're given the question. It is a minimization question. So you have to minimize a binary function, and it is subject to the constraint, which is a quadratic constraint. Yes, you can start.
Okay, thank you. So this question is not so difficult. We can use Lagrange multiplier. So this one is our target function. So we can create this function by using Lagrange multiplier. And then the way we can solve the solution is that partial L, partial x equals to 0, partial L, partial y equals to 0, partial L, partial lambda equals to 0. And then we can calculate this. This is not so difficult. Yeah, 1 minus 3x cubed lambda minus 3, okay, sorry, 4 square lambda equals to 0. And this also equals to 0, and the constraint equals to 0. Okay, now we are trying to solve these equations. So from this, we can conclude that lambda equals to 0 or y equals to 0. But note that lambda could not be 0, because if lambda equals to 0, then 1 will equal to 0. This is impossible. There were contradictions, so y must be 0. And then we can go to this equation. If y equals to 0, then x, we have this. And the solution of this is x to 0 or x equals to 1. And also x could not be 0, because x, if x could be 0, this one will also have a contradiction. So x equals to 1. And then we can calculate the lambda. But we don't care about this. We already have the solution. So if I use this method, we can get fx minimum is 1. Yeah.
Yes, I think the big picture of this question you give to me is clear. But just I want to note that this should be, I think this should be a plus sign, and right.
Oh,
so
yeah, right. I'm sorry.
Yeah. So the formula and your concept and your understanding of minimization by Lagrange is correct. So moving on to the second question. So you have to show that the minimum value of this is f00, but the Lagrange condition, which is nabla of f00 equals nabla of g00 multiplied by lambda, is not satisfied for any value lambda.
Any value of lambda?
Yeah.
So you mean this is not the minimum value of this function?
I mean, you have to explain this is not.
So you just mentioned 0, 0 is the solution, right?
Yeah.
Yeah. So I have to prove y 0, 0 is the solution.
No, I mean, no. So the Lagrange condition is this thing is here is the basic structure of the Lagrange, and you just simply to use the simplest word to tell me why why this is not satisfied for another lambda value. And the Lagrange condition here.
Okay, so I know what you mean. Okay.
Yeah. Use language as simple and understandable as possible.
Okay.
It is easy.
Lagrange multipliers can only be used if the function is smooth. That's the point. But I think maybe at this point, 0, 0, this constraint is not smooth, so we can't get the correct answer by using this method. So now let me show you that this will be 0, because if this will be 0, we can't use the Lagrange multiplier, right? So let me calculate this equals to x 3, 4 x cubed. At 0, 0 will be 0. Also at 0, 0 will be 0. So which means at this point, we cannot get the answer from the Lagrange multiplier. So generally, if I want to get the minimum of this function based on this constraint, first I need to reach out to Lagrange multipliers to get this answer, but this is not enough. We also need to try to find under this condition what value will be for the function, and that's combined together, we can notice that the minimum of this function is 0 rather than 1, because Lagrange multipliers cannot reach this answer, but this answer could be possible.
Yeah,
because at this point, the function is not smooth.
Yes. That is correct, and that is all for today's interview.
Okay,
Thank you.